Hello, my name is Shane Sweden, and this is the second part of our videos on HTTP response headers and their implications for security. In the last episode, we looked at why headers exist, what they're used for, why they can be good, and why they can be bad. If you want to check the headers as part of your own development process, creating unit tests and stuff, then it can be useful to have a utility that will load up the content of a web page, look at the headers, and give a judgment or a score on whether or not those headers are good or bad. And here we're going to go through a play-by-play where we develop just such a utility that you can use. And I hope you enjoy it. Okay, so the first thing we do is we start a new project. Now normally we would have a class library and stuff, but because we're just going to create a simple utility here, we're just going to choose a standard .NET console application, which will contain all our utility classes and even a program, because it's a very simple utility we're building. We're just going to call this secure header score. So this will be the name of our utility, our executable application. And so we create our project. And we have our first simple project, but because we're doing test-driven development at light variant, we're going to add, of course, a new project, which will be a test project. And this will driving our development. So we choose a unit test project. We'll call this secure headers tests, secure header score tests. Okay, we create that project as well. Now we have our console project, we have our test project. Our test project, of course, needs to reference our console project, which will contain all our actual classes. So we need to add a reference to that. Okay, so we're ready to start our test-driven development with our first test. So let's just rename our class here, our test class, to match what it is we're testing. And the first thing we're going to test is our scoring method, so our score utility. Score util. We haven't actually created this class yet. Let's rename our method for our first test. And we're going to test, of course, our header scoring. And for our first test, we will take the very simplest situation where a web page returns no headers. And therefore, we would expect a default sort of 0 score. That's very unusual that a web page would return no headers. Here we're using, as usual, the arrange, act, assert pattern for our unit test cases. And as part of our arrangement here, we're just going to create a list of fake headers, which will return. Now we're going to just, there's possible data structures we could use here, but we're just going to test out here with a key value pair. Okay, and these key value pairs will be a header name, which will be a string, and a header value, which will also be a string. So it's a key value pair string. So this list will be called headers. So we create our new empty list. And then in our act stage, we will evaluate the score, and we need something to hold the score. Now we have a positive result and a negative result. So we're going to create a tuple which contains 2 integers. The first integer holds the results for any positive headers we've seen, good headers, and the second can hold the results for any bad headers. And we're going to, well, first we should actually rename our class to represent the tests. Since we're testing, the method, the module we're calling will be called score utils in the secure header score assembly. Let's just copy that name to make sure we get it right. So inside that assembly, we're going to have a class which does the scoring, and which will have a method called score headers, and we'll send as an input into that class our key value pair list of key value pairs, headers. And then we come to our assert stage. Then we, as said before, we expect an empty list, so the result should be some sort of a 0 default. So the first item in our tuple should be 0, and the second item in our tuple should also be 0. We'll see our file's called unit test here. We should rename that to match the name of the class. So that should be score util tests. Now, normally, as I said, these utilities would be in their own, not inside the executable here, not inside the console program. They'd have their own separate class library project. But this is a very, very simple executable. We want to keep everything contained. It's just going to be a few classes. So for simplicity's sake, we're just going to contain all our utility classes in the same assembly as the executable. So we add a new class here, which will be our score utils. Now we want to be able to test this class, so we'll have to set the access level of this to internal. And we also need to make the assembly available to our test project, and we're going to do that using the internals visible attribute decoration, which identifies the test project as a friend, so that it can access, the test project can access internal classes and internal methods in this assembly. Now this decoration probably should be in the assembly info file, but it should work here. And so we need to get the name of our assembly, which is security header score tests, the same as the namespace in this instance. So we add that to our attribute. And by adding this assembly decoration, we should be able to now access our score utils class from our test project. And so in the score utils class, we want to have our method that we're going to test here called score headers. So let's just reference that, score headers, score utils. And we can now generate that method. So we have our first test ready. Now if we run that test, we should get an error here because we haven't implemented the actual method. So it should be a method not implemented exception. And indeed we get method not implemented exception, exactly as we had expected. Okay, so we should start implementing our method, and we can start off with checking to see if actually our headers list that we're saving as an input contains any headers. And we can do that using the count property. So if it's an empty list, then we should return a default 0 result. And we're getting an error because not all paths actually return results. So we can just, as a default here, we can return null. And of course, we're not returning a 0 here. We should be returning a tuple of a double 0. So we'll create our new tuple int with 0 values as our default result when the list is empty. And from that, we should be able to run our test and test the screen. Okay, that's great. First test working. Okay, let's create a new test where instead of an empty list, our list is null. It returns nothing at all. How do we handle that? So let's copy our last test and create a new test where we've got a null header. And here we would expect, I guess, some sort of exception. A web page should always be at least returning, our method should always be returning a list of some sort. So we'd want to generate an exception whenever we get a null list. Okay, so we need to change our arrange statement here. Instead of creating an empty list, we want to initialize it as null. And the method here will be returning exception. So we have to let our test know that an exception is what we expect. So we'll use a new decoration, an expected exception decoration, where we can tell it, the test unit test, that we expect to have an exception. The type of exception here, I guess we could try for an argument to null argument null exception. That seems appropriate. Okay, so we can run the test and see how it works out. And we get an exception, but not the exception we wanted. Here we got null reference exception as unhandled. Okay, this is not what we want. We want to handle exception that we expect. So what we can do here is we can add in some defensive code where we check the input to make sure that it's not, a null argument is not acceptable here. So we can check if the headers is equal to null, and if it isn't, then we throw a null argument null exception. So let's create new argument null exception, and we can give it a message saying it's not acceptable, headers cannot be null. If we get a null header, something's gone wrong somewhere. So let's just inform the user that's the case. Okay, now that we've created our new argument null exception handling, we can rerun our test. Okay, and the debugger stops at the exception we're going to throw, but this is just the debugger so we can carry on and let the test finish, and as a result we can see it's a green result. We got an exception, but we expected an exception. And we can take this opportunity to rerun all our tests just to make sure we haven't broken anything. And both tests are green. Okay, so now we've handled two situations, an empty list and a null list. Now perhaps we should test a case where we actually have a few headers. So we'll actually have to create a new test here. And this test won't be expecting any exceptions, so we can remove the expected exception attribute. Okay, we've taken the null situation and the empty list. Let's go to the next stage and have a list which contains one header, a content security policy header. Content security policy headers are a good thing, so that will give us a +1 in our positive score. There will be no other headers in the list, so we will have a minus score of 0, and we just need to change our arrange statement here from the null to a list with one CSP header. What does a content security policy header look like? Well, we can find an example of a web page that has content security policy header. And I happen to know that Troy Hunt implements CSP headers on his web pages. So using the F12 key here, we should be able to look at the headers that Troy Hunt's web page returns. So we press the function 12 key, and then we go to the network tab and reload the web page. So we find the network tab and reload the web page, and then click on the link, and we should see a list of the headers. And then of course the request headers and response headers here. So we can see that Troy Hunt's content security policy here is quite a long value, but we're not really interested in the values just at the moment. So we're just going to copy a little bit. Mainly we're interested in the actual name because we're testing for the existence at the moment of content security policy header, not actually what the value is. So we can create our list, which contains one item, and that will be our CSP. Just copy the name of it. And this will be the key in our key value pair. And then the value, well, the value is not really relevant at the moment, but we'll just copy that bit of the value that we are part of the content security policy from Troy Hunt's web page. And we'll use that as our value at the moment. Okay. So we have our list, which contains, we need to use a list constructor. And we need to instance, of course, in that list, a new key value pair of type key value pair string, 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 and string. Right, and then I think we're done. We just have to end the statement. Okay, so we have our list with one policy, one header, a content security policy header. And as a result, we should see that the positive score, the item 1 should be 1, and that the item 2 should be 0. So we can run our test and see what sort of result we get. And the test fails, which is probably not surprising. If we look and see what the problem is, we can see that object not sent to an instance and object. Okay, I think this might be to do with the fact that we returned a null way back then in situations that we weren't handling. And a situation with more than 0 items in the list is one of those situations which we're not handling. So let's go to our method and see if we can fix this test. Right, so we're handling when the list is null and we're handling when the list is empty. Now we have to handle, other than by returning just a null, we need to handle a situation when we've got a header in our list. So let's do a check control. So we're going to check for our content security policy header. And we'll just loop through each of the headers in our list and check if any of the key values of those headers is actually a content security policy. That way we know that the content security policy is one of the headers that is being returned. So we'll just check for each key value pair in the headers. We call this KVP. And we can test if KVP point key is equal to content security policy. Right, and that shouldn't be an underline, that should be a dash. Content security policy. Then we'd want to add 1 to some score. So let's create a variable, integer variable to hold score. We'll have one integer variable called plus score, which we initialize to 0, and another integer variable, which will be the minus score, which counts for the bad headers we have, and that'll also be set initially to 0. So if we find a content security policy, we can update the plus score by the value of 1. And we can return this result instead of a null as a new tuple made up of our plus score and our minus score. Okay, now we can run our tests again. And we have a green result on all our tests. It's great. So now we have tests for 3 of the simplest cases, where the header list is null, where the header list is empty, and where the header list is returned with 1 header, which we check for, which is a positive header, a useful header. So now we should perhaps create a new test where we have a perhaps more advanced situation, more complex situation. So we have to create a new unit test. And here we can maybe include a bad header being returned. So we have a CSP header, which is good. And we also have a server header, which is less optimal. So that would give us a score of +1 and a score of -1. So 1 good score, 1 bad score. So now we need to add a new key value pair to our headers list that we're scoring. And this one will be a server header. Now the server header just has the name server. It's one of the original headers from the HTTP protocol. And as a value, we can use something for perhaps Microsoft's IIS, Internet Information Server. Although it would be useful, for example, to look at the type of headers we get. So here we have a website which has an example of the server header. We can copy that value and use that in our unit test, because it's always good to have realistic values when you're doing a unit test. So we copy that value and we paste it into our value here. Although, as I said before, at the moment none of our controls are actually looking at the value of the headers, just whether or not they exist. Anyway, as expected for this test, we would expect a negative score on the minus part of the tuple. So if we run our tests and see what we get, and we get a fail as per usual on a new unit test, and we see we got -1, but we expected -1, but we got 0. So if we look at our unit test, we can see, well, we're not actually doing anything when we detect a server header. So we need to create a new control for that. And here we're going to check if the server header exists. And if it is, then we're going to subtract 1 from the minus score. And now we have a control in place. We can run our unit tests again. And we get a green result. So we're now able to test for both content security policy header and the less optimal server header. Okay, so here we have created the basic structure of a method which can score the different HTTP headers that it encounters from a web page. And obviously we could expand this list to include all of the different types of headers, HTTP headers that you can encounter in the real world that actually have an effect on security for the good effect or a bad effect. But we should remember that this scoring unit at the moment, it's actually just scoring an abstract list. It's not actually connected to the internet. It's not actually looking at the content from any web page. And in our next part of this video, we will be looking at how we actually score content from real web pages. So I'll see you in the next clip.